All right, in this session, we're going to look at lessons 41 through 43, and we're going to look at 4 different concepts, 2 in 41, 1 in 42, and 1 in 43. In lesson 41, we're going to look at reciprocal trig functions. And you guys know cosine, sine, tangent. What we're going to look at is the reciprocals of those, the flips of those. The reciprocal of cosine theta is secant theta, the reciprocal of sine theta is cosecant theta, and then the reciprocal of tan theta is cotangent theta. And so whenever we get something that says secant 330 degrees plus cotangent 480 degrees, all you do is you flip it and you make it, the opposite of secant is going to be 1 over cosine 330 degrees plus, instead of cotangent, you take the inverse of that, which is tan 480 degrees. You put both of those into your calculator. You find out what the decimal number is. So the cotangent is going to be, or the tangent of 480 is going to be 1 over root 3, or root 3 over 1. So it's like this. So it's root 3 over 1, which when you flip it and bring it to the top, it becomes 1 over root 3. Same thing here. This is root 3 over 2. When you flip it and bring it to the top, it becomes 2 over root 3. And then, of course, you have to fix, you got to get the radicals out of the denominator. You got to, and then also, the 1 over root 3 was a negative. So, because it was a negative, even though it's a plus. So, you get the radical denominator, root 3 over root 3, root 3 over root 3. So, this ends up being 2 root 3 over 3 minus root 3 over 3, which it becomes simply, because it's implied 1, it becomes root 3 over 3 is your answer to this one. On these reciprocal trig functions, it's what you've already been doing. The only difference is you have to flip it before, your calculator, get the reciprocal. So right here, these are in radians, so we have to take them 2 degrees. The pi's will cancel. 4 divided by 180, I believe, is 45. Yeah, 45. So you get 3 times 45 is going to be 135 degrees. But it's cosecant. Cosecant is 1 over sine. And it was a negative. So sine of negative 135 degrees. And this 2/3 is, you'll multiply after you figure out what that is. Then you have 11 pi over 4 times 180 over pi. That will cancel. Same thing. You have 45. 10 would be 450. And then just add, so it'd be 495. So secant is 1 over cosine. So it's cosine 195. Whenever you put them in your calculator, what you end up seeing is they both end up being 1 over root 2, and they both end up being negative. So we have our 2/3. Now when you flip it, it's really cool with these kind because it just becomes root 2, but it's a negative. Then right here, 2 negatives is a positive, so it ends up being a positive. Once again, also this is just root 2. So it becomes negative 2 root 2 over 3 plus root 2. We need to get common denominators, which would be 3 over 3. So that it becomes simply root 2 over 3 after you add those together. This next concept is called permutations. Not too tough a concept because you're just going to be using a button on your calculator The button on your calculator you're going to be looking for is the nPr button. It'll be a little N, big PR, and a big P, and then a little R. This is the permutations concept. No big deal right now, but here in the future, you're going to get a very similar concept. You got to understand the difference between the two. Two different buttons on your calculator. The N stands for number of things. The R stands for take an R at a time. And some of these problems are going to be like this, where simply they give you a problem and it says 12P4. All you got to do is enter that in your calculator. Super simple. Other ones are going to give you a word problem. And in a word problem, they're going to tell you you have 22 things taking 6 at a time. You just got to make sure that 22 is your first. It's just 22P6. And then it looks exactly like that. And you just press the button in your calculator. If you struggle with these, we can look at it in class. The next concept we're going to look at comes from lesson 42, and it has to do with circles. You're going to need this in your formula page. This is going to be the formula that you use in order to discover everything. Whenever they give you the center, it's H comma K, and the H and the K are plugged in right there. And then R stands for the radius. So in this first example, they're going to say, find the standard form of the equation of a circle whose radius is 4. So the radius is 4. And the center, which is HK, is -3, 3. So you're going to plug these numbers in there. And what they want you to find is the general form and the standard form. We'll start with the standard form. Not real difficult. It's going to be really easy at first. And then we will baby step up to the tougher stuff. So we got the square root of x minus, and h is -3, whole thing is squared, plus y minus 3 squared equals r. Now we're going to square both sides. When you get that, oh, we do know r is 4. Square both sides, so we get 16 equals x plus 3 squared plus y minus 3 squared. And this right here is one of our answers. And this is in standard form, okay? But then in order to get general form, we actually have to multiply this out and get it all equal to 0. So we got one of our answers already done. That was not difficult for you. So we have x plus 3 plus y minus 3, y minus 3 equals 16. So we get x squared plus 3x, and 3x is 6x plus 9 plus y squared, -3y, -3y is -6y plus 9 equals 16. So you end up with x squared plus y squared plus 6x minus 6y. You have 18, bring the 16 over, so plus 2 equals 0, and this is general form. This is what general form looks like. Not too tough, but we're baby stepping up to a much tougher concept, or at least more involved, more understanding later on. The last concept we're going to look at is called sinusoids. And I know this looks very intimidating, and it's a really long thing, but I promise you it's not. What this is just a lot of decisions and choices to make. You'll always start with y equals, and then you'll either put plus or minus the center line. And if it's 0, you actually don't have to put anything there, which these first ones will be 0. Then it's a positive or negative sinusoid. Let's say it's a negative. And then the range just means it's like 3. It means just how far it is. And then it's either a cosine or a sine. And then it'll have some sort of a period, but that's later on. And then it'll be theta or x. And it'll be a plus or minus and a phase shift. So it's really just a couple of questions here and there. There's not much math to these at all. You're just going to look at a graph and write something down. Now at this point, but you need to put this whole thing on your formula page and just put a sinusoid. At this point, you're not going to do half of this, but you will over the next 10, 12, 20 lessons. All right, look at the one that you're going to look at here. You're going to have something like this where it goes, that's what kind of what these things look like, and you know, here's your center line, and this is 180 degrees, this is 0 degrees, this is 90 degrees in the middle. In the middle is 90, so we have 270 and 360. And we have, this is at 0, the height here is at 6, this is at -6. This is a super simple one. Now, I'm going to show you the difference between a sine and a cosine. So first off, it's going to be y equals, what's the center line? It's the center line that goes through it. It's at 0. So if it's 0, there is no positive or negative. It's just 0, so we have to put anything. Now, a sine, now sinusoid, don't get that mixed up with sine and cosine. It's just the name of it. But this is a sine function because it crosses through the origin either on the way up or on the way down. Now, if it crossed high or crossed low, it would be a cosine function. So, and then the range of this thing is from 0 to 6. So how far is that? 6. So the range, and because it's on its way up from the origin, it's a positive. So it's a positive 6. So there's your range. It is a sine function, and it's going to be theta, because there is no period and phase shift at this point. That's going to be for later on. Really, there's no center line at this point. Right now, you're just learning this part. I think they're all going to be theta, so I don't even know if x. They might put it on here. On this one, they did it as theta. The next one's going to be x. So you do need to figure out if it's theta or x. So put that on, but that would be the answer right here to this function of a sinusoid. I'll show you the next one's going to be a cosine. All right, the last example we'll look at it's a cosine one. Now remember, on the sine one, it was crossing right here at the origin. It was on the way up. And that means it's a positive sign. Now if it was crossing right here on the way down to form all these, it would be a negative sine function. Remember I said a cosine function will cross, and this is the y-axis right here, it'll cross the y-axis low or high, but not down the middle. Down the middle is a sine function. So this is a cosine. Now, if it's down low, it's going to be a negative. Now notice we have 0, -3, and +3. These are super easy at first. So there is no, the center line is 0, so there's no positive or negative right here for the center line. Now it's at the bottom, crosses the y-axis at the bottom, so it's going to be a negative cosine function with a range of 0 to 3, a range of 3. And it's a cosine function because it crosses the y-axis either high or low. This time it's low, so it's a -3 range cosine function, and it's going to be an it's x just because they said x here. The other one, I think, is here at the end. The other one said theta right there. No big deal. No period and phase shift at this point. So this would be the answer to this type of problem. All it is they give you a graph and you have to label the graph. Not too bad.